We talked about the field lines. These are nice illustrations so that now you have a better understanding for the electric field. When you have a source charge that is positive, field lines will be going radially outward, as you can see here. They are all originating from the same center. So we have spherical symmetry. If the charge is negative, then again you have spherical symmetry, radial direction, but the direction of the field is going inward into the center. So this is a sink, while this is a source. Okay. This is called a monopole. Mono means one. It's a positive monopole. This is a negative monopole. The electric field usually is taken as tangent to the electric field line at any point. And the number of lines per square meter can be taken as a qualitative description of the intensity or strength of the field. The stronger the field, the higher would be the density of field lines. Usually, when we draw field lines, always the field lines should start at the positive and end at the negative. Here you have a positive charge near to a negative charge. When you have such an arrangement, we call this dipole. Dipole. Di means two. So here you have two poles. Rather than saying two poles, we say dipole. Dipole configuration. The field lines, if you check on any field line, it starts at the positive and ends at the negative. Now, if you check on these field lines, you will note that none of them overlaps with any other line. None of the field lines overlap with any other line. It's very important. So field lines cannot cross. Field lines cannot crop. Okay? And they always start with the source and end with the sink charge. Here we have two positive charges, so the field lines are repulsive. As you can see, they will never, the field lines will never cross each other. They will cross each other. If you have two charges that are different in magnitude, then this is not a dipole. Okay, because the charges are not of the same magnitude. So you have this sketch for the field lines. Again, they go out from the positive and into the negative. The other observation is that the field lines will always be perpendicular. The field lines will always be perpendicular to the surface. Will always, the point they enter or they leave, they will always be perpendicular to the surface. Rank the magnitude of the electric field at points A, B, and C in the figure. Largest magnitude first. Any suggestion? From symmetry.
Oh, sorry.
From symmetry, what can we see about the figure at C?
It's on the middle.
It is zero.
Yeah.
The field is zero from symmetry, right?
Mm-hmm.
So this would be the least.
Yeah.
Now you are now you need to talk about A and B. This is nearer to the source, right? So the field at A need to be stronger than the field at B. With this in mind, what would be your answer?
It will be number one, right? Yeah.
I agree. It
Yes.
would be number 1.
Yes. Thank you. Yeah, it will be A, B, C.